Hello, my pretties. Here we are on page 2 of the logarithm notes where we're actually going to graph our log functions. So we're going to graph the parent function, then graph h of x using transformations. We're going to identify the asymptote, domain, and range. So our ADR, we always do our ADR. All right, so parent graph is just the natural log of x in this case, because we have h of x equals the natural log of negative x plus 5 minus 3. Okay, and natural log x is going to be our parent graph, but what I'm going to use is the exponential function to figure it out first. So I'm going to do e to the x because we already know how to do e to the x. I'm going to just use a couple points instead of the negative one as well. 0 and 1 is fine. So e to the 0 power is 1. E to the first power is 2.7. But exponential functions and log functions, again, are inverses. The basic inverse, all you do is switch the x and y. So the 0.01 becomes the 0.10. The 2.7 becomes the 2.71. So that gives us this red graph right here. So I don't care about this graph. This is the graph I'm looking at. I just used this to find this, and then I ignore it. I don't care about it. So this is our parent graph. We have that negative trapped on the inside, which says reflect across the y-axis. So I'm going to reflect over. So now I get this green graph. And then this is going to move to the left 5 and down 3. So left 5, down 3, left 5, down 3. And remember, these are inverses of the exponential function. So instead of a horizontal asymptote, we have a vertical asymptote. So the vertical asymptote also moved to the left 5. So that's where our asymptote is now. X equals negative 5. Domain, well, we're to the left of the asymptote. So x is less than negative 5. And the range for log functions is always all real numbers, so we like that. We don't have to think about it. All right, so B, h of x equals negative log of x base 2 plus 6. So again, all I care about is log of x base 2. That's the parent function. But to get to there, I'm going to start with the exponential function of 2 to the x. So 2 to the x, I'm just going to plug in 0 and 1. So again, 2 to the 0 power is 1, 2 to the first power is 2. So then to get to the log function, all you have to do is switch the x's and y's. So 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. And now we don't care about the 2 to the x anymore. All we care about is the log function. That's the one we're actually graphing. So these points give us this red graph, and that's our parent graph. The negative out front says reflect in the x-axis. So if you're on the x-axis, you stay there, but if you're below the x-axis, you're now going to be above it. If you're above the x-axis, you're now going to be below it. So this little green graph is the reflection. And then the plus 6 says move up 6. So I'm going to take the green graph and I'm just going to move it up 6, and we get this beautiful purple graph. Now, we didn't move left or right, so the asymptote is still the y-axis. So our asymptote is x equals 0. The graph is to the right of the asymptote, so the domain is x is greater than 0. And yay for log functions, the range is always all real numbers. This side of the graph keeps going up, this side of the graph keeps going down. And that finishes page 2 of logarithms.